So let's get started. So guys, last week we take the first class in Z notation, and last week we just maybe take a very simple example, okay, which is the counter. The counter. So the aim of that example only to show you how's the structure or what the structure of Z notation look like. So I think now you know how the structure and what the main components of Z notation. So anybody tell me what's the main components of the Z notation? We are building the Z notation or Z specification, not Z notation, yes, Z specification from something. What's that things? Guys, what that things? We are building
Scheme.
the Z schema. Thank you. Yes, schema. So anybody else can you tell me what's the different type of schema? We have one is the main schema should be in every specification, which is the first
State.
one,
State schema.
state. Yes. Why we say state? Because it's, you can say, is define or declare the variable of the system. So in the state schema, we declare the variable space, as they say, this variable space. That means all the variables it's required for the system. So for the second schema, it's
Initial.
the initial, yes, and the initial is if it's required, okay. And the third, maybe we can say it's not only one schema. One is many schema is the operations. So the operations, it's maybe it's really 1, 2, 3. So it's based on the system requirements. So in the Z, in the space, or we can say in the state or the space variables, there we define the structure of the system, structure of the data, the structure of the database. We can say, I mean, just I want to refer you to the database because you know. So in the state schema, actually we define the structure of the data, how the data will store in the system. In the operation, what we do, we model the behavior of the system. Okay, so there in the first, in the schema, state schema is the state, the structure of the system, while the operation schema, it's for modeling the behavior of the system. So once we say the system is able to add user, delete user, so this is behavior. And this one is work on the state schema. So the state schema is, you can see, the structure of the data. Okay, guys, so keep this one in your mind. And the state schema almost in every specification should be there. But in the others, which is the initial and operation, is not necessary. So the last week, as we say, we just take a very simple example. Like we cannot even call it as a system, but it's okay as a system, which is the counter. So today we'll see a system. That means something is need the data structure or not the data structure. It needs the data to store the data. We can see data structure and need also the behaviors. I mean, we have two aspects. So in order to model the system, we have to know, we can see the elements of Z notation. So this is the outline here, the elements of the Z notation. Once you have any system, for example, student and class system. Any system to model or to management this the student and class. So we need to save this data, store this data in the database, and then we need to do some operation. So in order to do that, in order to write a specification for that, we have to learn the elements of Z notation. Of course, we have to learn. So then we have also something we call it the set, the subset of under relation. This is the topic function, and the end we will end with the birthday. But before we go, we will start now with the birthday. We will not start. I just give you what we need. then once we go for the element of the Z notation, so you will know why we take this thing, why we have to learn the set, why we have to learn the relation, why we have to learn the function. Okay, so I give you now, we explain this problem, the Z, the birthday book example, and then we will go by for these elements or these outlines one by one. So guys, this is the description of the birthday box. Okay, birthday box actually is just a system, a symbol system also. Record the people birthday. Only this word is enough, but okay, maybe more explanation. We need to record the person, the name of the person. Only we take the name. Maybe later, if you want to improve it, you take the name and other information of the person. But in this specification, we just want the name. Okay, name. And the second, we want the birthday, which is we can say is the date. We want to store only the name and the date. Okay. So okay. So let's continue. This is for this one for the data. If we say what we want to store and what we want to record in the system, this and this. So what the else? Here also we want to issue a reminder when the dates come around. Okay, so the system should issue reminder when the dates come around. For example, today is 22 or right 22 of 24 22, yes, 24 22 of December. So what we have to the system do, the system should issue reminder, okay, to send, for example, a reminder for each person that he has this today or tomorrow is birthday or today is birthday. So this is the first one, issue reminder. This is the system should be able to issue this reminder. Also here there is another things is the system it's able to add a person. Actually this is the main things, and then as uh, requirements, other requirements, the system should able to add a person, also find the birthday by name, find the name by giving date of the birthday. So here I will see just a very simple example. Just we have the name and the dates, and then we want to do this operation. Very simple example, right? Understand this example, guys? Faham? Hello?
Yes, sir.
Are you? Yes. Okay. Oh, I thought. Okay, guys. So, guys, now I have a question for you. How does the database of this system, you see what we say, we have only, we want to store the names. Let's see only names like this and dates. Okay. And then we want to system just add add the birthday or add the person, add the birthday, and then find their birthday, also find the person of the dates. So some operation here, okay? And then we start this one. So what do you think about the database? How this database look like? Of course, now you have different opinion. Maybe some of you they say this propose and the other one will propose another things. What do you think about the data or the database of this system? Guys, hello guys.
Yes, sir.
As I told you, you should whole day with me now. Whole we have 2 hours, just maybe less than 2 hours. But I explained the system. I explained this system, right? This system, which is the birthday book. So now I want to ask what's the database, how the database look like, what we need to model this system. Okay, no, don't talk about, no, I'm not talking now about Z notation. Just before you go for the Z notation, just thinking how the database look like, and what the tables are needed in the same arts actually, what the table are needed for this system, and what the operation for this system.
You will have a person table.
Okay, we can have a person table and
And a birthday table, which
person table. And the birthday table is okay, good. Well,
Then
this is good. It's, I think, as we say, okay, we wanted to make it simple. It's okay. I think it's the correct one, this one, right? Anyone have a different opinion? Or we just proceed with this? I think is the correct one. We have the birthday, we have the person. So as we say, we can later, we can extend these tables. So here we just say the birthday, we just store the name. Okay? And the birthday, or we can say at least we can take the dates only, because the birthday that we will take will add the dates here, right? We'll store the date. Okay? So for the operations, okay, as you know, as I explained, the operation is adding person, deleting, and others. So here, actually, this is the proposal for this system. We can do that. We can do that. Okay. Maybe as they propose here, we can have a table. For example, table is now for the person. Okay. And then we have the other one is birthday. So the birthday will not store this data. We just store the relation between this person, the person A with the dates, the person B with dates. Okay, so something like we have exactly person and we have birthday, and person have only the name, and there we have the date, and birthday have the date. So and then we have the relation between them. So we can say, okay, this is also can be implemented. Okay, so we want to now do this thing. We want to model this idea using Z specification, using Z notation. Okay, guys. So now if I back to the outlines, you will see, okay, why we will take now, we will see the set. Because we will use the set there. You see our example now, the birthday, we use the set. So why we need the relation? Because as you see here, we have relations. So the same thing here, that the relationship is actually the relation between the sets. Also, we have a relation and function. We have different functions. So why we need this one? So today only we need to model this system, but we need to know everything about these things, which is the set and the relation and function. Okay. So we just want today to know how to model this system. Okay, so let's see. As we see, we'll start with the elements of the notation, which will help us. With these elements will help us to model this system. Okay, guys. So don't forget now the birthday book example. But okay, now keep it aside, and then later we will back to this birthday. But even you can continue thinking. Okay, when we talk about the set, so how we can use the set. So we say we want to add. We know how to add. I mean, how we can add in the set. Is it a set? So how I can add one person in the set. Okay. So let's start with the elements. So first, guys, as we say, maybe now don't think about the Z notation. Just say the types, for example, the element of Z. The first one is the types. Okay, everything in Z notation must belong to set. Set. Okay, and this set it's called types. Okay, guys. So now when we talk about, for example, the integer number, that's similar to the last week example. We just say 1, 2, 3, 4. So this is the integer number. We cannot just use 1, 2, 3. No, we have to. I mean, especially if we use variables. So we have to. I mean, this set should belong to, or this number or this variable should belong to set. It's either is integer, real, anything. Okay. So any set or anything used in Z notation should belong to set, and this set is the type. So you can use the basic type, like for example the Z, or you can define your own one. So here, what we have here, red, yellow, green. This is not a basic one of the basic type, but this is its free type. So you can define your own one. Okay, you can define, for example, this is the color is the set. So what this color, it's red, yellow, green, something like this. Okay. So either you would use the basic type or you define your own one. So here is some of the basic sets or types. So is the integer, the natural number starting with 0, or it's strictly, that means starting with 1. Okay, r is the real number, and then here we will back for this, but this is also, we sometimes we use something, some set is we define the set, but not exactly. We don't say 1, 2, 3, or one don't say red, yellow, green. No, we define it or we describe this set. Okay, it's important, this type of sets. So here example of the set, either the set that's its basic one or the basic type or the defined one, and here is the null. So in the notation, okay, actually I already know how to define, actually this slide only to define the variables. Okay, so it's easy, just x and then the tab of, or I mean the variable is then the tab of this variable, either is integer or strictly integer or real, or even your three types. So okay, this is all is set. So here, guys, we have now is also it's this is related to the to rely this topic also, which is the power set, to the variables or the types. Okay, the types and the variables. So here also how to define your own set. Okay, so actually, okay, let's this is aside. I will give you an example. Okay, we have our example. We say person, right? So we can define person as a type person. Person, me, you, this all is person. Okay. So how we define this person? Define, not declare, define. So now I define. Now similar to the integer, similar to z, we have something we call it person is type. So later when we want to define a set of this type, for example, as we say, we have there is noun, right? Noun is list of person. A noun is list of person. Our example, the birthday one. So what we have to do is define this, no, and then B. So this is the B, which is something like is double line. B person. Okay. So here, what you can see, this is the type, and this is when we see B person. That means this is set of the noun is set of this person. Okay, guys. So here is similar. We have another example here. We have a book. It's as a type. We define the book as a type. Okay, and then we have some set we want to define from this book. For example, we have loan book. We have, for example, some reference book. Okay, guys. So what we mean by B now, as we say, we have, we continue this example, which is the book. Book is a type of, we can say is the type of data. Okay, is a book. So we define some set of this book. So this set, for example, on loan. So any book on loan. So this is, we can say we have a set of book. This is on loan. And we have some reference book. So this set is, we can define it as B book. Okay. So later we can say on loan is subset of this book. So here another example. I mean, just okay. We see it's the power set also the same. If the power set of A, B, C, the power set it's actually is the, we can say is the collection or is the contains the elements of all subset. The elements of all subset. Okay. So here we have the element, the null, we have the subs. Okay, the set with one variable, the set with two variable, and the set with all three variables. So a B, C or power set, the elements is the collection of all sets. And then later we can define some of these sets. Okay, guys, let's see. Maybe someone is request. No one. So, guys, let's continue. As I told you, is sometimes we define or we need to define something, some set which is similar to this set. So in this set, actually, we call it is the comprehension set. So what's this actually? This is actually exactly is the set that you see. For example, you see the integer set, 1, 2, 3, 4, and then. So this is exactly the same, but here we describe. We not write the elements, but we describe the elements. Okay, actually this is very useful in this Z notation, so you should to understand this well. Okay, you should understand how to write or how to describe the set. How to describe the set. So, for example, okay, let's first see what the components of this comprehension set. So first one is the declaration type. The declaration. So first we need to declare the elements of this set. This set belongs to what type or what kind of elements. For example, here integer. Okay. So the second one is the redact. Okay. Actually, this is just true or false, and this is a condition. Okay, is a condition. So this is actually we can say is a preposition, or we can say the one we use it in OPAL, which is the first logic, first order logic. So actually is a condition. Okay, in this time it's just condition. Later we'll see what the first order logic. So here the second one is the condition. For example, here we say is the integer. So the condition here, this integer must be less than, the element of the set less than 5. Okay, so we can say the set. It's not the set exactly. Later we say one, the element, the x. If I talk about x, the value of x. But this one, if we say this is, for example, this is s. So x, it's 1, 2, 3, 4. Okay. So how about s? So, but later s should satisfy this expression. Okay. Okay. Now we have 3 elements: the declaration, the redact, and then expression, which is the term that should meet or should satisfy. Okay, the expression that we evaluate this value based on this term. So here, if you see, as we see here, this is x. You see now I define only the x value. So, but how about s? S should be square of x. So it's 1 multiply 1 times 1, it's 1, 2, it's 4, 2 times, and then 9 and 16. Okay, guys? So you should understand how to convert the normal set to this comprehension set. Also is the reverse, how we can, if we want to describe a set, or if we have a set, how we can derive the elements of this set. Okay, guys? Here the description that I explain here, as we say, the parts of this comprehension set. Okay, the same actually, the same. Just here is more details. Okay, we have first is a reduction, or the first is that we define the types of these elements, and then the reduct, which is the condition, or this is the constraint. Okay, the constraint or the condition that should be satisfied, and then we have term or expression. We should evaluate the system or the or the elements of X or the set based on these elements. So we have got some example here. So here it's, if you see, it's not all the elements or not all the parts is compulsory. Some it's maybe not available or not mentioning here. So it's okay. So we have here X. So we can say this is the declarations, and this one what? The redact, if we say is B, right? So in this, we can say is this one is just all the elements. You can say the natural non-integer number. Okay, this is the integer number, and this is empty set because this is never satisfied. And this is also, this is just they told you, okay, this is not the same. Okay, so here this is the example. Okay, sorry. So guys, here maybe what you see, this is example. What we have here, is it the same? From n, and then we have, I think these are the same. Okay, this is an example of comprehension set. We have 1, 2, 3. Okay, from 1, maybe we should write here 1, because we see it's directly starting from 1 because we don't have 0 here. Okay, guys, and then we miss 16. Okay, guys, no problem. Next example. So, guys, this is try to solve this example. Guys, what the elements of this set? First here, guys, we have 2 elements. That means this set is bare. Okay, that means S equal to bare. For example, x1 and y1, then x2 and y2. Okay, so it will look like this. So guys, what the elements of this? Hello,
1,
guys.
4, 1, 5.
Okay, 1,
1
4,
bracket 1,
then
1 5 bracket
5,
2, 4 bracket
then 2. Okay, yes, and then to the end. Yes, thank you. Your name? Your name, the one, the answer.
Oh, my name is Mui Fong.
Hello. Oh, okay, thank you. So we need another one now. Another one. You see here we have only the prediction, right? And then we have not the prediction, the definition, and then reduct. Okay. So this is the answer. Okay, the same how you answer. Okay. So now we have the same also, the same example, but here we add another expression here. So what do you think the answer? I mean the element of this set. Actually, we can just keep this in your mind. X plus 2 equal y. X plus 2 equal y. So maybe we should see, I mean, all the example here, I mean, all the elements. And then we see which one is plus 2 equal y. So here we have, for example, 1, if we add 2, we count 3. So not equal y. But here 2 equal 2 plus, okay, 2 plus 2 equal 4. Yes, become y. And maybe this is the first one. So let's see. Okay, so the elements is 2 and 4. And then the second one, because here also 3 plus 2 equal 5. Okay. So just guys, just see how we can find the elements and do the same thing if we have and we want to describe this set. So how we can describe it. Okay, guys, we use this one many times in Zen notation. We need it. So you should understand how to convert from the description to the set, to the from the elements to the comprehension. Okay. So let's go to the next, which is the operation on set. So this is so easy. No need even to give you, just okay. I will go very fast. Okay. Here, this is keep in your mind. When we want to find the number of elements in the set, we just use hash. So hash something like counter, like count. Okay. So the hash is count. So the second thing, if we want to add here another operation, if we want to have this element and we want to combine elements, we should use union. So maybe later you will not add. So the other one is the difference. Okay, and this is just used for, if you see here we have 1, 2, 3, 4. So we have here 2 and 3 only. So now after the operation become only 1 and 4. That's mean 2 and 3, it's deleted. So we use this one for removing. So the intersection, use it to find the intersection. Okay, this is just a very simple information. This is, they say it's error, cannot use something like it because it's different types. So this is the same, I think I should to go. Okay, same. So this is new, is a complement. Complement, that's mean the other set or the other elements of the operation. Okay, not set. We have sometimes in the universal or the universal set. So if we have A, for example, 1, 2, 3, so is this the other elements is the complement set without the element of the set. So here I just explain also. Okay, guys, I think just skip all. So guys, for the next is the subset relationship. So what we mean by the subset relationship actually is the same. We have some operation, but they not only to combine two sets. No, this is the relation of two. Actually, we use it for compare to set. Okay, for the comparison. So here, actually, also the output of this expression or the preposition, we can say it's true or false. True or false. For example, we say X is member of S. So if we say what's the output of this, so that's why we use it every times. I mean, we use it to use it in precondition. Okay, so this kind of the operation we use it for precondition. So here we have X, it's elements, right? X is elements. So we say X is member of S. So if it's member, that means this it's true. If not, that means it's false. So the second thing is not member. Okay, the third one is subset. Subset, that means we have both of them is set. This is set and this is set. But while the first one is element and set. So it's subset. The other one is, the last one is proper subset. So it's the same. Let's go ahead. So here some operation we can be used in Z notation. It's just also it's just the additional and subtraction and multiplication. This is all. It's easy. Maybe it's just maybe the last two. It's max A and max and minimum A. So this is retain the maximum number and then retain the minimum number. Okay. Okay, guys. Now we have this new topic. Is important and not new topic. Actually, it's all topics, or we already learned how it's this, but we just revise because we need it now, and I know most of you is already forgetting. So guys, the relation and the function. Okay, guys, anybody know what's mean the relation and the function? Or what the difference between them? What the difference between the relation and functions? I have to go to you now. Hello?
Yes, sir.
Yes, I asked a question.
Relation can have
Yeah, a lot.
many output, but function like one output.
Okay. Okay, in general, guys, before I start, actually, we say relation, anything, any mapping, any pair, any mapping between, if you have, for example, to sit. Okay, let's see the slide. I mean, I want to just open the slide because maybe. So here, guys, if we talk about the difference between them. So for the relation, any mapping between two sets, we can call it as relation. Okay? Any set, any mapping of these between two sets is a relation. While the function have some conditions. Okay? So every element of x is mapping only to one element of y, for example. This is the condition of function. That's mean in the first set, there is no repetition. There is no two elements mapping to the first, the same product, same elements of set of y. Okay? If not clear, I will explain more, but just stay with me. Okay, first, before we go for the define the relation, actually we have here a topic which is we call it is Cartesian product. Okay, so what this Cartesian product? Okay, if we have here these two sets, first one is we can say is, for example, A, and this is B. Okay, so the Cartesian product actually is all the pair, all the possible pairs. Okay, all possible pairs from A to B, because A is the okay, I can say from now is the domain, and the B is the codomain or the ring or the image. Okay, so here we have here A and B. So any relation between A and B. So this is or the product. Okay, now is the Cartesian product is all the relations, all the pairs, all the possible pair of these two sets. Okay, so if you see here, it's x if A x A xb. So here is we list all these pairs. Okay, we list all pairs. So see now we have I'm just give you this example. I mean this topic just to show you what's the relation. So any subset of this set, you have now the set. Okay, so the Cartesian, if you have any subset of this pair, so this one we can say it's relation. Okay, for example, I take only, for example, the first three. So this is, as you can see, is a relation. That means x. I mean, if we take the first three, that means we take only x. We have x and y and z. Here 1, 2, 3. But our relation only mapping the first element, which is x, and with all element of b. First element of A with all B. So this is relation. Any subset of this Cartesian product is relation. Okay, guys? This is the definition of the relation. Actually, this is the one I said. What I said is, so any subset of the Cartesian product is relation. So if we take some, this is if we have AX, as I explained in the previous slide, we have this is the list of this AX. So if I take some of these relation, for example, as we see here, we take x with all elements and z with all elements of P of B. So this is relation. Okay, guys, this is the relation. So let's go to see the function. So the function is the relation, it's relation. So maybe it's all possible, maybe some possibles. Okay, some possible from A to B or all. So, but we have a condition that in which each input has only one output. Okay, each input has one output. That means A linking, for example, with B. 2, 1. I say 1 with B, for example. 2 with 3 with Q is okay. This is acceptable. But if we come here, we have 2. You see, 2 is linked with 2 elements. So this is not function. We can see this relation, but it's not function. Okay, you know why, guys? Because something like we say f2, and then we find the y, we can say, or f2, it's, for example, it's b. Okay, and then we have the same thing, f2 get another another value. Okay, the first time is b, in the second one time is q. So it's not acceptable. So this is not function. Okay, guys. So why we learn functions and relation? Because we have to define the function and the relation in our system. Once we write the invariants, we should to say, or we should, once we write the declaration in the state variable, in the state schema, we should to mention the type of functions. We should to learn from now how we can identify the function type. Okay, that's why we learn this thing. So let's continue. So here just what we mean, what I have explained. Just we say x is assigned to one element of y, not to two elements. Okay. So later here we can represent the function with different graph. We can say we can use the arrow graph, or sometimes they call it what? Mapping. Okay. Mapping graph, or arrow, or graph, or plot. Okay, guys. So this is how we can represent later, maybe, because today we'll use this arrow diagram to represent this type of functions. So here is just the domain and the rank. As we say, we have x, for example, and b. So here, all the elements, I mean, if we have the function from this to this. So the type, okay, the element of x, for example, if we have function here, function, so the elements that linking to y, so this is the domain, and this is the rank. Okay, so the elements of x is the domain, while the element of b is the rank of the function, not another elements. So here also how we can present also, or we can know the rank and the domain. Okay, you know this one. You just, okay, if you see here we have the domain, that's mean in the x, but here the y. So this one, okay, guys, okay, I already braced. This one, it's function or not function. Just like we say, is it function or not function? Just tell me why is function. It's already there. I already state here, I mean function, but why function? Why function? Hello, guys.
Each input has one output.
Yes, each input has one output. Okay, this is the explanation. Each input, we have one output. Okay, so it's the same. It's the same, but actually, I think no, this is not function, guys. This is not function. This is the function. Actually, I think there is some mistake here. Just maybe because sometimes I duplicate the slide, so I did not change the photo. So here actually not function, because we have two is mapping with the same, with two elements. Number two is mapping with two elements. For the first one, I think I have to change the slide, the figure. Okay. The explanation is different. You see here we have diagram of the function with domain 1, 2, 3, and the codomain is A, B, C, D, which defined by the set of. So here, if I say 1, 2, 3, and here A, B, C, D. So here we have, if we say is the function, here we say 1 with D. Where 1 with D, and 2 with C, and 3 with
A or
3 with C. No A here, no A.
why?
A is not linked with anybody. So it's okay. It's okay. What we say, we don't. It's not necessary to. We just model this thing. Okay, no need. A no have here. We have A, B, C, D, but A is not mapping with any elements. It's okay. So here, guys, you see this. This is function. So this is actually this is wrong. I mean, this is the figure. This is for the second slide, but here for this slide should be A, I mean 1, 2, 3, and then we have 1 map with D, 2 map with C, and 3 map with C. So this is function, okay? Because all elements of of X, for example, if we see X is mapping with different elements. Okay, for this one, not function, because we have only one element, which is 2, is mapping with 2. As I told you, something like if you mathematics X is equal to, I mean, if X equal B, and then the same thing if 2 is equal to C. So it's not logic. If function, no, cannot. But here we see is, we have different. It's okay if we have, for example, F2 equal to C, and then F3 equal to C. It's okay. Sometimes it's come like this. Okay? Because if, for example, if we have, no, this is different. If we, many example. So, okay, guys, this is the function and not function. Okay? If we have something like this, so two element or one element is linked with 2 or mapping with 2 different elements. So this is not function. Okay. So this is the function definition. As we say, is it's assigned exactly one element of fx. Okay, this is the function. This is what we just said. Okay, this is different type of function. Sometimes we have one-to-one function, and sometimes not one-to-one function. Okay, so if you see here, each one mapping with 1. Here, not one-to-one, but okay, still function, because mapping with no two elements mapping with the same numbers. So here, not even function, as we see, because the same number mapping with 2 elements. Okay, so this type of function, but now we have different type. This is okay, but we have now different types. Okay, you should focus on this because this is with the explanation. Okay, okay, guys, please, this is important. So, guys, we have partial function and we have total function. So what we mean by this, as we know, the function should assign with each element. Okay, so here some member of x. So maybe I have another slide. Okay, but let's explain here and then we go for the next slide. Some member of x. So we have x and elements. So some member, for example, we have a, b, c. Okay, and then here 1, 2. So here we say some member of x is mapping with y. Okay, so this is, we call it partial function. So how about the total function? The total function, all elements of x is mapping with element member of y. Okay, so maybe, for example, we can say c with 2 also. So this is total function. That means all the elements here. So we have another one in the injection. So some member of x, the similar, some member of x bear with difference. So this one, this kind of relation not acceptable in the injection. We cannot say B and C map with the same number. So this is not injection, not total, not partial. Okay, so should be different. Okay, so here we have, for example, A, B, we have here 1, 2. For example, A mapping and B mapping with 2. So cannot say now C mapping also with, cannot. So if we see like this, so this is injection. Still okay, injection, because we not map C with another elements of this. So how about the total? The total, that means we have also C should be mapping with another elements, and that means with different. So we have another elements here, for example, 3. Okay, so C mapping with 3. So this is the total. The total does mean all elements of E, it's mapping with another element. So we have the last one, is the bijection. Bijection, actually, okay, for example, this is actually, we can say is bijection. Why? Because all the elements of Y, it's cover. Okay, all elements of Y cover. So this is, you can see, is total injection. Also in the same time is projection. Also this function is 1-to-1. Okay, guys. So now just the same, but just I give example. Okay. Okay. That before we give this example just what we can say, it's based on the description. Maybe if different description, the same example, maybe it will be different function or different type of functions. So here, just based on this description, for example, we say, guys, you should follow this symbol. Different function have different symbol. So if we talking about the partial, so it's this symbol. This is arrow, different arrow. So each one has different one. So once you write the specification, you do also select the suitable one for you. Okay. So let's see now this some example. As we see here, we have the total function. That means every element of X is mapping to Y. So here, if we see the city, if we look to the city, any city must be in a country, any city. Okay, so for example, we have C1, city 1, city 2, and city 3. So city 1 in country D, city 2 in the same country, and city 3 in another country. But here, since we talk about the total, so every country, every city must belong to a country. So what the next? The next is partial. Partial here, if you see the different, here all is mapping. So there is not all mapping. So here, if we say, okay, based on this scenario, a group of students go to any restaurant and then everybody order something. Okay, not everybody, some of them, based on this scenario, some of them order, some of them don't order. For example, this is order, this is don't order, one is not order. Okay, so and some of them maybe they can share. Some students share the same, for example, meal, or we can just say like this. Okay, so this is now the partial function. That means some of them they don't order anything, so we can keep the some of them, or the first one, for example, it's not order anything. So this is become partial function. Just an example. So it's based on the description. If I change the same description for the same example, maybe it will become different function. So here we have another example. Okay, another example here. Okay, what we say here, I think we have student and then borrow a book. Some student borrow a book and some student don't borrow. And some books not borrowed by any student. So this is, we say it the injection because as we say, some student but different. I mean, we don't find now one do like this. I mean, one guy, because we say if you borrow a book, of course your friend, you cannot borrow the same book. We say here book, that means because in nowadays they not the book the same title, no, the book with ID. Okay, so if you take the book, even the same title, but you have ID, so your friend will not come to borrow the same book. Maybe they will borrow the same book title, but not the same book that the one you take it. So here we can say this is partial injection because two persons cannot borrow the same book. Okay. So here is the total injection. That means everybody, the total injection. The total injection, that means all elements of X, it's linked with Y. So here, example, we can say lecturer and office. The relation between them, we can say belong to. So this office or this office is belong to these lectures. So every lectures have one office. Okay, every lecture have one office, and some they don't have. Not some they don't have. Some office not belong to any lectures. Okay, maybe for discussion, for any things. Okay, so just example. Why we give this example? Because later when you see the example or the system description, you should to define what kind of of relation or function needed. Okay. So bijection, for example, is the flag. We can say, okay, each country have national flag. So also the same thing, if you have the list of the flag, so each flag is belong to one country, not belong to the national flag, belong to one country, not for too many countries. Okay, so as we see, this is just example. So there is another function, but this is maybe the one it's the most used. So I just give example for each one. There is another which is surjection and the other types. So here another topic, not topics, the same, just a few things. Okay, you know this is now is the bear. This is how we represent the bear. Here mapping is the relation actually. Mapping is the relation. Here's the first element of bear. If we have this bear, so we want to take this element, so we just say first B, second B. This is the second elements. And this is if we have binary relation, something like bijection. Okay. This one, it's also the domain and the ring. Okay, if we have the relation of the function, so if we want the domain of this relation or this function, so we just say domain R or ring R. Okay, guys, we give this one because we will use it. Okay, I don't want to give anymore. This is actually is also the same thing that we use it in any other language. Okay. What? Okay, I want to reach here because I feel you are not with me anymore. Look, guys.
Yes, sir.
Yeah.
Yes, sir.
Are you okay, guys?
Yes.
Yes. I don't know. Okay, guys. I hope you are with me, still with me. Okay. I just want to show to see you. Can everybody write 1, 1, 1, 1? I want to see how many 1 I have.
How many ones you want?
Oh. I just want you. I want you. Just I don't want the one.
Okay.
Okay. Thank you. No. Okay, guys. Actually, because as we say, this knowledge already old knowledge, and we need it. We need it, and maybe it's boring, but this is the new topic is coming now. So you should to know now how to model this system. We will back to our system now. So is the birthday book. Okay, birthday book. So guys, this is the database that we seen in the first slide or the second slide. So this is the database. Now we want to model this system, this birthday book. So now you know how to define this set, right? You know how to define the type of this, right? Because we already know. You know this now, the relation, what's this relation, right? Because we know already know. You know how to add now. I'm asking you, that's mean I say yes, you know. Not asking, I mean I say that because I say you are, you know that. You know now how to add, right? If I want to add another name, for example, this is Johan Milk and Susan. I want to add any another one. I want to add the Lisa, okay? Like this. I want to add her name to this list. How I can add? Or if sometimes I want to add her name with the birthday directly. So just, okay, how we can add? Any answer? How we can add? Guys, that means I'm talking to myself. I don't know if you was with me or not. I show you and I told you this is we'll use it for adding. And I told you the another one for delete. I told you this is we'll use it for delete. Guys, we are talking about set, right? Set. So we have this element. I want to add another element.
Just put comma and
Okay, I'll show you the set. No, cannot do like this. We are talking something like programming. Later, we want to translate this thing to code. You cannot just, okay, I add this. Because you know what? That's mean add. That's mean you have some data in your system, right? And then you want to add. So you'll just add. I mean, you want to make develop a operation, or you get develop function, not function the one we learned today. No, the function that you learned, procedure to add person. How to add the person in database?
Union, sir.
You just huh? Again?
Union.
Yes,
The
union. Yeah, union. Yes. We just use union. I told you when we passed that slide, I told you this one we use it for this. When we go to the difference, what I told you, we use it for what? The difference, the symbol like this, right? Like this or like this? I don't know, like this. If we have set, the set 1, 3 elements, and then we have, for example, 1 elements. For example, A, B, C. And then if I have here A, that's mean the different, what will happen for this set? It was A, B, C. Different A become
BC.
Delete.
B, C. Yeah, so we use it for delete, for removing. As we see, guys, as we say, this is what we will write later, or what you will code. That's mean here, we just write first, you cannot first version of code, just a simple abstraction of your code. Okay? This one can be translated to code, guys. Later, once you say, oh, this is now I have the idea of adding person. Okay, later I just write the code. Maybe I can either check if this function it's work or no. Okay, guys. Okay, I mean this is why we take all this thing. Now I spend 1 hour just for see the set and adding the union and the difference, and then so this is all because we will use it. We will use it. So let's see how we can use it. So guys, we have here the noun is the set. So we need to create now the type of set, and then we create this, or we define this set. Here how they define the relation. We can define as your friend say, okay, two types or two set, not one set and one. It's both actually two set. This is two set, but the second set is type of the relation. The second one is the relation, not just element. Okay. So let's see now. The first thing, actually, this is now if we talk about the state diagram, state schema. So this is the state schema. So now we go and translate this is two variables. This is the state schema. We just want to translate these two variables. So if you see, that's mean we will have in our state schema, what we will have, guys? Just I want to remove all this. Okay. In our state schema, we should have variable, it's called noun, which the type, this is actually the type of person. We will define the person. And the second variable, we have another variable, which is birthday. And the type of this, not set, but relation. Okay. So as you know, we should have also invariants. Why we have invariants? Something like the safety in our system. So if you see here, what you see here, this relation, we have 3 elements, right? And in the noun set, we have also 3 elements. If you see here, we have this one, the same, this one. This one, same, this one. This one, same, this one. Okay? So this is the invariant here, we should do mention it here, which is this element, or the first part, or the first elements of this relation must be the noun. Must be the noun. I don't want later, I have here another Nisa, but it's not here. So how we can make sure that we have only the birthday of this name, This relation only store the birthday of this name. We just add here the condition, which is we say the domain of this relation equal to this set. Okay? Okay, guys. So let's see now. This is how we can write it. The complete, actually, I already explained here, the complete state schema. So here, the same thing, what we say. Okay, first we have to define these data types. So now we define the three data types. This is our data types. We can either say name or person, but here we say name. Okay, the date is date. So later here we have one set, the first set, which is the noun. The noun is exactly this set. It's our set, the name. That means we have a lot of name, but we have this subset of name. We call it name noun. Now we have a birthday, the relation between them. The relation between them. We have relation from name to date. Exactly what we see here. Okay? The relation between the date and name, the name and the date. Okay, and the second and the third is the invariance. As I told you, we want, okay, based on our system, we want all these, the domain of this relation to be is the noun. Because later, why we use this one? Later we cannot, we don't repeat some record. Okay, we will not repeat some records. Just to check, okay, if I want to add a new record, I will check what I will check. I will check the noun. Okay, so the noun, no name there. So, but if I don't write the domain, so maybe the name is not here, but it's already here. So this is the condition. It should be satisfied in whole system. Okay, guys. Okay, this I just explained what it means. So this is the state schema, and this is just to compare both of them. So guys, here, this thing they say, okay, maybe we can add here some limitation. Because here, as you see here, that this invariance say the noun is the domain of the birthday. As I say here, this noun will be the domain of this birthday. So just this. So as they say, if we want to add, for example, one invariance, we say that our record must be less than 100. Okay. We don't have enough memory to save or to record more than 100 person and birthday. So how I can add this? Should add it here. Okay, before or in front, it's okay. So how we can write it here? How, guys? Yesterday group they answered this question. Hello. I just told you today. You see, guys. In the beginning, I said this can return the count of the set. The count element of the set. What things? There is a very simple thing. We use it in everywhere. Use it in Twitter, use it in WhatsApp, Facebook. Huh?
Hashtag.
Hash, yes, hash. Hashtag hash. Yes. So we just want to, if I want like this, I just say, for example, I can use the noun. For example, I say the hash of this noun, or either without brackets, noun, should be less than 100. Okay? Okay, guys, this information I give you before is not just I give you because I have free time. No, because you have to learn. Not whatever I give you. No, because we need it. We need it. Actually, guys, I teach this subject now maybe 30 years. But every time I change my slide. Every time I change, and sometimes I delete. I say this is not necessary. Okay, guys, now if you want to add, okay, this is you already answered. See, it's so easy, lah. The sentence for adding only this. So we want to add, we have this relation. For example, we already now we have set of relation, set of the relation, which is the birthday. We want to add a new one. Okay, we have, for example, the Lisa, and her birthday is, for example, 12 December. Okay, so I want to add it to the birthday. Just use union as you answer, as your friend answered. So here is birthday. Just let's see, capital birthday. Okay, and how about the new birthday? What is different here and here? Should add something. So this is the new what? Prime. Okay, we should add prime. What is the difference between this and this? This is, if I add prime, that means this is the new value. While without, that means the old value. So we just use union. So this is now anything I add. Actually, guys, if you see here, we add many times. We don't add the value, the variable itself. I mean, we don't add the value. We add some variables, and this is later. I will explain something about it. Okay, this is what we call it is first order logic. Okay, first order logic. That means it's not a preposition. It's preposition, but with variables. Okay, so here we use it. Actually, we use it. So okay, now this is adding new record. So we just here we add this precondition. Why we add this precondition? This is what I told you before. We want to make sure that this person not added before. Okay, so I add the noun. Okay, the name, which is the new name, the new record, not member of the noun, not member of the noun. Okay, so this is a precondition. Name, which is the one we want to add it, not a member of the noun. And the noun here is the domain of birthday function. So guys, here, okay, maybe you already know why we put this question mark. We put question mark because both of them is input. The name and the date is input. So we put question mark. So here, okay, no problem. This is just okay. If you see here, guys, we use delta. We use delta with the state schema. Delta, because we shrink. We have here prime, so we shrink. But if there is no shrink, we use Z. We call it Z, and some they call it she. So it's Z. Okay, this operation. So if there is no shrink, for example, you just want to print or to display, you want to find, so there is no shrink. So that's why we use this Z operation. So here to find the birthday, exactly, guys. If you see, sometimes we have fx. Okay, we have, for example, this will bring you y, right? If you have the relation between x and y. Okay, this is the element, not the set. So we just do like this. So here will be the name of the function, which is the birthday. For example, here birthday Nisa. This should retain the birthday dates. Okay, and refers. If I want to the dates, I can find. I mean, if I have the date, will retain the name. But this is have another issue. Later we will see. So, but this is for finding a birthday by name. We just have the name as an input. The name as an input. So we put it, or we pass to the function, and then they return the dates. Okay. So here the question mark because name is an input, and the dates with exclamation because the date is the output. So this is the operation for finding the birthday. Okay, operation to find the name, but we have the name as an input. We want the dates, so we just pass this name to the birthday function, and then they return the dates. So it's so easy. Anytime you need to find another pair. Anytime you want to find another pair, you just send the one pair, and then they will retain the other pair. Okay. Anytime you have here, for example, two set. So this is it's already pair, it's already function. So if you have the elements of x, you will get the elements of y. Okay, just if the function and then the elements, you will get the other elements. Okay, guys, I hope it's clear. I hope it's clear. So we have the last one. It's a little bit, I told you have, when I explain here, I told you if you have the birth date, if you have the name, you will retain the dates. If you have the dates, also should retain the date, the name. But here we have a small story I have to tell you. Okay. If we have now, if we have the name. Okay. And then the function of the birth date. So here, based on the previous example, which is find the date or find what? Find the birthday, should return the date. Okay. But he is not working as expected because why? Because what, guys? Because what? The previous slide we see we have, if I have the date, I will return the name. So easy, no have any complicated, no have any errors. But here we have errors. We have something not function well. Why? No, wait, guys. The reverse. Actually, if we have the dates, I mean, if we have here, if we have the birthday of the name, we will get the date. Okay, but if we have the date, birthday date, what we will get? Birthday date, we should get
The name.
the name. Okay, but I told you here before, this is what we have, what we work here, and it's worked well. Don't have any problem. But here we have problem. In the second one, we have problem. What do you think is the problem? And that's why we sit. Okay. What the problem?
Maybe we have two names.
Yes, exactly. Yes, exactly. We have in the date, for example, this is what we say. We want to issue reminder for list of people. For example, today, a lot of people the same day, their birthday is today. For example, a lot of people they have the birthday today, right? So here we have list of not only one name. We have a list of names. List of names, that means we cannot use one variable to return this value. This is number one. We cannot use only one variable. So we define here set of names. So the card is set of names. If you see here different here, we don't add B, this power set. We don't add, but here we add because we have a list of names. So here also the second issue, we cannot use exactly this function. We will use it, but not direct. We should to use comprehension set. Okay, we should to use the comprehension set. So here you can imagine something like this comprehension set. We have something. We have list. We call it noun. List of noun. So this the set of noun. I mean this is list or set. For example, have 10 person. This is noun. Okay. The noun have 10 person. So we want to go one by one. We want to check this element one by one. Anyone, his birthday equal to their birthday, today dates. So we should to save this guy in the card. Okay, guys. We have list of noun. The name is noun. The noun here is the list of names. So we want to go through this list. Okay, we have A, B, C, D. For example, this is the list of names. Okay, we should to go through this list of names one by one. One by one. And any of them, her birthday or his birthday equal to today, so we should to save this to the card. So how we can write this one as a comprehension set? So we use this type. You see here, something like 4 from 1 or from 0 to noun. Okay, and then we say if here, if the noun or the birthday, because we say if it's birthday, if the birthday of this I equal to, for example, this is I from 0 to 1, from 0 to noun, to the maximum number. So if this birthday I, it's equal to today, so we just save this one to the card. Okay. Okay, guys. So this is what we say here. We have, this is the data types. The types of, we have n is the element that we can say n is the variables. Okay, n is the variables. So the n is any one of this, the function, any name from the noun. N, it's any name from the noun. So it's only, we want to take not all of them. We just want to, the one whose birthday is today. So here the n, something like n, like counter. We will go through this set from 0 to the, or from the beginning to the end. Okay, so anyone satisfy this condition, the birthday equal to today. So because here the n is the name, right? So will be the first name, is the first name equal to today? I mean the birthday of the first name equal to today dates. If okay, just save here. So the second one, the third one, until this noun is completed. Okay, guys? I think it's okay. Because nobody, it's okay, I think you understand. Okay, guys, so easy. So easy. If you have any question, please ask. Okay, this is the initial, I think is no need to explain. Just we reset, we don't reset, guys. You see, we reset the noun. Just once we start our application, we have to reset the set. Here we just reset the noun. So also we don't reset the relation, because the domain of this function is already reset, which is the noun. Okay, so here one different type or different form of writing the schema. You can write it in one line. Okay, the same, but you can write it in one line. Okay, we done, guys. Any question? Please ask.